want you to think about this logic that I just went through. Okay, how I literally went from like the most basic level. I only know the gradient, I only know the intercept, and I'm going to take advantage of what I know about quantum geometry to arrive at a formula. I'd like you to have a go at deriving the formula for point gradient form. You know what the formula is, okay? It's not complicated, it's not very different to this one either. How would you start from the most basic facts that you know, which is just a point and just the gradient, and arrive at the familiar result? I'll give you a few minutes to have a think about it. We're doing point gradient form now, and you can see I'm going to go about this in a very similar way to how I went through gradient intercepts, right? Remember, for this, I began with the intercept, that was 0b, okay? I don't have an intercept at this point, I have some point off in space, anywhere. So I'll start with that. I pass through this point, I'll just define any of the points on here, and I'll call that the point that my line must pass through, okay? Once I've done that, in order to have a gradient, well, a gradient is a comparison between 2 points at the very least, right? So therefore I need this second point up here, and I'll call that xy, just like I call this xy. That represents, this is a really important idea. I'm just going to tease it now, I'll tell you the name of it, and we will deal with the topic at the end of the year. This is called a locus, right? A locus, it's this idea of a set of points that all behave in a certain way. They all follow the same rules, okay? So yeah, it's another way of looking at these familiar equations, okay? We're going to deal with that as a proper topic later on, but just so in a few months' time when you're like, oh, you mentioned this thing, it's like, why are you talking about bugs in class that eat crops? No, not locusts, locusts, okay? So,
it is like the locust.
Kind of. Now that I have a point, I can define its gradient, right, like so. Okay, and it doesn't take you that long to realize, okay, your rise is going to be y minus y1, right? And your run is going to be x minus x1. So I'm playing exactly the same trick I had before. I've got y minus y1 on x minus x1. That's equal to the gradient by definition, right? That's how I constructed the diagram. So therefore, just one line, there, voila, is our point gradient form. That's it. Now, as Jinsu has pointed out, it's not really worth a whole extra diagram for it. If instead of passing through 1 point, right, and having a gradient, I get given 2 points, which, by the way, is exactly the same as being given a gradient, right? If you're given another point, that defines the gradient for you. All you need to do is take this guy here, right? So this is in its current position, its point gradient form. All you need to do to turn this into 2 point is to change the gradient into how you work out the gradient when you have 2 points, namely rise over run. Right? That's m, isn't it? Right? That's our formula for m. Now that's being multiplied by this, and this is what's on the left-hand side. So all I need to do is see, oh look, this x minus x1, let's group the x's together, and this y, let's group the y's together. Okay, so if I divide through, I'm going to get this. Y minus y1. And voila, from point gradient form, now you've got 2 point form. Okay? They are the same thing. These are all the same thing, just seen through different lenses. Okay? Worth mentioning, occasionally you will see, instead of y minus y1 on the top and y2 minus y1 on the bottom, occasionally you'll see that flipped upside down. Right? Does it matter? No, because if you've got that flipped, you'll have this flipped as well. It's the same fraction. Okay? That's right. Okay, so whichever form you've got it in, so long as you have everything matched up. The way that I tended to write it when I was in year 11 is I did all of the y1s and x1s first. I write minus y1 because I know that's the same. I write minus x1 because that's the same. And then I just put the rest of it wherever I want, really. It depends on what you're after. Okay, the last one, 2 intercept form, is the least common, but in some ways it's the most useful. So let's talk through it. I'm not going to leave you to your own devices on this one, because it's a bit trickier. 2 intercept form. Okay, let's have a go.
No, there's just 2. You just name the x and y, x2 and y and x.
Alrighty. So, I'm going to derive for you two intercept form, and it's a brilliantly simple equation once you get there, and it's very, very practical, as you'll see shortly. But one of the problems that immediately presents us with is I'm going to use general form, which you know. I'm going to use general form as my mechanism to derive, like it's my starting point to derive this, okay? So immediately, like I have letters that I can't use, and I need to find, okay, two intercept form. I need to define a y-intercept and an x-intercept. So I have to give them some names, some values, okay? So to try and avoid ambiguity, like calling this B, but there's already a B there, or calling it capital B and lowercase b, which is just as confusing. I'm just going to call this beta and alpha. Okay, I know we normally reserve that for angles, but it's just not enough letters that you guys are very familiar with that I can use. So I'm just going to go with that. Okay, now if I've got a line, and by definition I've said it passes through these two intercepts, okay? Just remember back to when we did the gradient intercept form. Those 2 points, those two intercepts are coordinates. They have coordinates, right? What are the coordinates of each point? What's this one?
0.
It's 0 beta, right? 0 comma beta. What about this one?
Alpha.
Alpha comma 0, right? Okay, now if I know the points on the line that satisfy that line, that means that they satisfy the equation, right? So I can take this, sub it into here, I can take this, sub it into there, and those statements should both be true because the points are on that line. Does that make sense? So I'm going to get two equations out of this. Let's do it, right? We'll take, let's do the x-intercept first, okay? So that's x is going to be alpha, y is going to be 0 plus c. Is that all right? Okay. Now let's just tie this up a little. So this is a alpha plus c equals 0. Now at this point, right, what am I trying to work towards, okay? There's so many letters here, it's easy to get confused. Alpha and beta are some known values. You know what the intercepts are, right? They might be 3 and 5, or 18 and 200, okay? But the point is, they're numbers, you know what they are. A, B, and C, they are the unknowns. That's what I'm trying to get rid of, okay? So I want to solve for A, B, and C. Now, for reasons that will become clear as we go through, rather than make C the subject, I'm going to make A the subject. So I've got A alpha equals minus C, right? So making A the subject, I've got minus C on alpha. You happy with that? So I have a value for A now, whatever that is, okay? If I repeat the process, this was my first equation based on the x-intercept. If I repeat the process for the y-intercept, I'm going to have x is 0, so A times 0 plus, help me out here, B times beta, and there's still that constant flying around over there, okay? I'm going to simplify in exactly the same way, and I'm going to end up with dot 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 B equals minus C on beta, okay? It's literally exactly the same thing. Okay. So now I have a value for A, I've got a value for B. I'm going to put them back into my original equation so that I don't have A's or B's anymore, okay? What am I going to have? There's A, so it'll be minus C on alpha x minus C on beta y plus C. You happy with that? Just a straight substitution back into my general form. Okay. Now you can perhaps see why I chose to get rid of A and B, because now look at what I've got here. Remember, number 1, this is all equal to 0, right? And number 2, you've got all these C's here. So what would you like me to do to simplify this? I'm going to divide through, I'll go one step better than C, I'm going to divide through by minus C. Okay? Just make it a tiny, tiny bit neater. All my C's are going to vanish and all my signs are going to flip. So I'm going to get 1 on alpha x, 1 on beta y, minus 1. Okay. Now I could stop there, to be honest, but just like there's conventions and that kind of thing, this traditionally is not where we stop. We traditionally stop one step further. And that right there is two intercept form, okay? So, if you might have seen this before and not known what it was, if I know what the two intercepts are, I said 3 and 5 before, okay? So if I want the equation of a line that passes through, what have I done? 3 over here and 5 over here, then its equation is going to be x on 3 plus y on 5 equals 1. How would you convert that to general form?
Times 15.
I would multiply by the something that will eliminate both denominators. So I'd go 5x plus 3y equals 15. And then to be a bit cheap, I'd just move that 15 over to the other side. Done. Okay? In exactly the same way, suppose I didn't want general form. Suppose I wanted to go from here to here and get the gradient, and it's, well, I already know it's y-intercept, right? How am I going to do that? If I want
Minus
gradient form,
x on 3.
I want y as the subject, don't I? Right? So I guess I would multiply it by 5. That would make this 5 over 3x plus y equals 5. And then I just rearrange. Minus 5 over 3x. Which, sure enough, that looks like minus 5 over 3, doesn't it? You can see how ingenious this is, because, like, why does it work? If I were to put in x equals 0, that's how I find the y-intercept, isn't it? Right? Well, watch what happens. When x equals 0, this guy just disappears, right? So therefore, y equals beta, which is what we defined from the first place. And in exactly the same way, if I let y equals 0, this thing disappears, so you get x equals alpha. Okay. Now, the reason why I love this, I said this is a very practical form, is because, you know, just as frequently, like if you're going to graph something, one of the things you're known to have to put onto the graph that you draw is the intercepts. You must put those on. It's like the most important feature, right? So if I just magic up some, you know, some equation like this, 2x minus 3y plus 8 equals 0. Okay. How do I work out the intercepts? I could do my x equals and my y equals and all that kind of thing. But how can I take advantage of this form? Here's what I'll do. I want my x and y on this side, and I want a constant on the other side. Does that make sense? So let's just make this a little bit neater. We'll just do that, okay? I'm going to add 8 to both sides. So 2x minus 3y equals 8. Okay? What do I want on the right-hand side? Not just the constant, I want 1. So I'll divide through by 8. So this is going to become x on 4 minus 3xy equals 1. You happy with that? I've already found my x-intercept. Bam, it's sitting right there.
Yeah,
this one takes a little more work, but not that much. In order to get that on the denominator, I just need to flip it upside down, right? So this is actually y over minus 8 over 3. Can you see that? I've taken the reciprocal so it goes on the bottom. Bam, there's my y-intercept. Not bad, eh?